Alright, so in this problem here, we're asked to find the general and particular solution of this given function here. The derivative f prime of x is equal to 2x plus 1, and they give us this initial condition where f of 1 is equal to 3. Now, we solve this problem the same way. The only thing is that here we have to find a general and our particular solution, and the particular solution comes into play with this initial condition that they give us here. But let's start off by finding the general solution. So if I want to find the general solution, then what I'm going to do is find the antiderivative of this function here. So I need to think of a function whose derivative is 2x plus 1. Well, if I think about the antiderivative of 2x, so I'm going to write here f of x, not f prime, but f of x, because I'm going to anti-differentiate. So if I think about the antiderivative here of 2x, I get x squared plus, and if I think about the antiderivative of 1, well, that would just be x, because when I take the derivative of x, I just get back a 1. And then I have to tag on this plus c. So essentially what we did, and I could have written it like this. I could have said that f of x is equal to the integral of 2x plus 1 dx here, and take the antiderivative of that and compute this, and we get out this thing here. We get out this thing right here. So essentially I didn't write out this notation, but I should have. But this is essentially what we're doing. We're finding the antiderivative of this 2x plus 1. Now that is our general solution. If I want a particular solution, so now I want to get a little bit more specific, then we use our initial condition here. So our particular solution. Okay, so what I'm going to do is now I'm going to take my antiderivative. So I'm going to copy that here. I have f of x is equal to, we have x squared plus x plus some constant c. And what we want to do is figure out what this constant c is. Well, we go back to our problem. We say, well, look, f of 1 was equal to 3. So if I plug in a 1 for x, so if I plug in that 1 for x, then my problem becomes, let's see, I'm going to have 1 squared, right? I'm going to have something squared plus, again, something that's our x plus our c. But remember, we're replacing all our x's, we're replacing those with 1s. So a 1 will get plugged in. And if I clean this up, I will have f of 1 is equal to 1 squared. 1 squared is just 1, and 1 plus 1 will get 2, so we'll have 2 plus some constant c. Now, keep in mind, to solve for c, I need to figure out, well, what was f of 1 equal to? Well, if we go back up here, we see that f of 1 was equal to 3. So what I can actually do is just say, well, hey, this thing right here was just equal to 3. So 3 has to equal 2 plus c. And if I move the 2 over, so if I subtract 2 on both sides, 3 take away 2 is 1, and we get 1 is equal to c. Now here's a mistake that I see a lot of students make in class, is that they'll circle this c equals 1, they'll put that in a box, and they'll say, I'm done. That's my final answer. But that's not what I'm looking for. I'm not looking for c, I'm looking for the function. So I want to know what the function is. So you have to come back up here to the original general solution here that you originally had, and plug in what your c is. So your final answer would be f of x is equal to x squared plus x plus 1.